Okay, I guess.
It's Friday, my dudes.
Okay, anyway, let's finish up the notes for example 5 on what is this? 4.3?
Yeah. Can't you start your own videos?
Yeah, I do it all the time, but it gets kind of boring. It's kind of interesting when you guys do it. So anyway, so it's the same stuff all the time, and that's very monotonous. I need to have like a video intro with like explosions and me walking away dramatically.
You should start it with you burping and say, let's get wrecked.
Okay, just stop right there. All right, so let's take a look at this problem right here. So we're going to do all those steps. So we numbered the steps 1 through what yesterday? 1 through 7. Yes, it is 1 through 7. So we're going to do that.
Again?
Yay! Can you use the same voice?
I could do my very...
Do a different voice each day.
Are you recording this?
Yes.
You said you
All right, so all right, good. Anyway, all right, so now, first thing. So my step 1, class, step 1 is my...
It feels so awkward with the light on.
I know. Okay. All right, so my amplitude. What is my amplitude on this one?
-1.
-1.
Do you hear swiper?
All right, anyway. All right. 2 is period. So period is going to be what?
-2. Oh, wait.
Okay. Tangent and cotangent always start with pi. So what's going to be on top? Now, class.
Yeah.
What is the b value here, class? 1. We get the 1 from this number right here. This is a 1. It is the only one. Over 1. Okay. All right. So, anyway. All right. 3. What do we say 3 was?
That's the one. Yeah.
Phase shift. Now, on this one right here, my phase shift.
-pi/4.
Okay. My phase shift is going to be...
-pi/4.
There we go. Right? Now, because we don't have a b value here, my b value is 1, right? If I divide it out, I still get the same number.
What if the b value was like a different number? 2? How do you...
You mean if the b value was 2/3, how would I do that one right there? I would have to factor out the 2/3 in this form right there. Okay, that's what. So, anyway, all right, so we have phase shift. Now, what else do we look for? Step 4. -2. So what does that mean? The vertical shift being -2, what's it do? The whole thing goes down. So the whole thing moves down too. Right? So I know we're not texting about this right now, so we're paying attention. Okay, thank you. All right. So step 5. Asymptotes, right? Now, we're dealing with cotangent. 0 and pi. Very good. Now, we multiply by what?
1b.
1 over b.
So it's 1 so that's 0.
Okay.
Then we have
So it's just going to be
the
0
minus,
pi.
right? A minus a negative pi/4. So it's going to be positive.
Wait, what? I already wrote it in pen.
Okay. Why am I using this? Because doesn't this move everything?
Yeah.
My phase shift moves everything over. And it's always opposite of this, right? Because if it's on the inside of the parentheses, moving it left and right, it's always opposite of the sign. Okay? So now this means if it's minus, that means it's going to move it to the right. If it was positive, it's going to move it to the left. Okay? So and that's why we have minus here to adjust for that. Okay, so now that's going to give me something here in a minute. All right, times 1 over 1. Stop. Okay, 1. Come on. You can do it. All right, 1 minus negative pi over 4. 0 times 1 is
0.
So this turns into just what? Positive pi over 4. Very good. So this thing is going to be my what? My start. It's my first asymptote, right? So this is going to be my start. And that's what I'm going to be dealing with here. Okay? So this is my start. The next one right here. So for this one right here, I multiply this. So this is going to be pi plus pi over 4.
So it's 2 pi over 4?
Pi. Here, I'll do the math right here. Pi, right?
Oh.
Over 1 plus pi over 4, right? Because minus and negative becomes a plus, right?
So it's going to be 5 pi over 4?
Yes, very good. It is 5 pi over 4. And so these are my two asymptotes. So these are my bars in which that my graph contains.
Now you need the parts, right?
Yes. Now, step 6 is my parts. Oh, I'm sorry, my dude.
Wait.
Okay. Yes, what? What's wrong?
Oh, nothing. I already got it.
Oh, okay.
Yeah.
All right, step 6, my parts.
So we don't really have to do zeros.
No, it's adding.
Yes,
Not multiplying.
because that's going to be my start. I don't have to have the 0.
You just start at 1.
Very good. I started 1/4 just like I did yesterday, right? So I do 1/4 times, so it's 1/4, 1/2, and 3/4. Okay.
Explain to me again why you need 0.
Because you just
But yeah, because I have my start over here.
Sorry, I can't see it.
then the second point will be the double.
Okay. So when I'm doing sine and cosine, I include 0 because I don't have an asymptote. And so I include my 0 in my parts. But because these are asymptotes in which that when I do the math, if I actually do the math right there and try to plug it into the function, I get undefined. So I really can't do the math, so I have to do it differently. Okay? So if you try to actually put these numbers in the calculator to get your value at the asymptotes, you're going to get undefined. So it's not going to work out. So we pull these out and work on them separately because we know where the asymptote is supposed to start at. But then because of the period changing, the phase shift, okay, those are going to move my asymptotes left and right. Okay, so that's why we do it like that in step 5, where sine and cosine, we did not do that. All right, so I multiply by what? What am I multiplying here? Period. My period is going to be pi. Now,
Oh.
plus
Plus and then wait.
Plus what? Plus start.
Oh.
Okay, it's going to be pi over 4. Now, I use the start because I've already incorporated the phase shift going the other direction, right? So I can't just put, okay, remember before when we did sine and cosine, we went minus and then the phase shift, minus the phase shift, right? And that adjusted for it going the opposite direction, left and right. And so I took care of that already when I did it over here for my start, okay? So now, if I know where my start is, I'm trying to partition my line out as to see how much of my line I'm going to have. Okay, so now it's not starting at 0, where the sine and cosine ones that we were doing would normally work with. So we're starting here, okay, and we're adding this much of my period. So if this is my start, I'm adding 1/4 of my period. So that means it's going to be my first step. Okay, the next one, adding half of my period. So that just keeps moving to the right more. Okay, eventually if I were to do 1, I would end up in my ending, which is my second asymptote for this. Does that make more sense? No? Maybe? Yes, my dude.
No.
Yes. What, my guy? What's wrong?
You lost me.
Okay, now speak.
No,
Say something math related about how I lost you.
How do you get pi and pi over 4?
Okay, now, what's this say right here?
Period.
Period. When I do my parts, I have quarter, half, 3/4. You got that, right?
Yeah.
Okay, my period. I found my period up here in step 2. Yes?
Okay. Yeah.
And then my start, I did over here in step 5, which was my first asymptote.
Oh, okay.
Okay?
Got it. Yeah.
And so that's why I have it labeled right here. Okay, so next one, I'm going to have, so pi, right, plus pi over 4, pi plus pi over 4. So mathematically, this is pi over 4, right? Pi over 4 plus pi over 4, which gives me 2 pi over 4, right? Okay, which is? Very good, pi over 2. Okay, this is going to be pi over 2 plus pi over 4. Okay, this is, if you notice, different denominators, so I have to do the trick, right? Yeah, the cross thing, right? So it's going to be 4 pi plus 2 pi over 8. So that's 4 pi plus 2 pi is 6 pi, right? Over 8, 6 pi over 8 is 3 pi over 4. Very good. 3 pi over 4. Okay, do the next one. So the next one over here, it's going to be 3 pi over 4 plus pi over 4. Yeah, it's just going to be pi. They're already a common denominator here, right? So I don't have to do all the cross. But if you did the cross, you're still going to get the same answer. Because it would be 12 pi plus 4 pi over 16. So 12 and 4 gives me 16 over 16, right? Yes?
Yeah.
Okay, yeah. So they're same parts already. So it's going to be 4 pi. Yeah. So it'd be 4 pi over 4, which is just going to be pi, 1 pi. Yes? Okay, so now there's part 6. 7. What is 7 going to be? Graph. So we're going to graph 7.
So you.
Okay, so step 7 is my graph.
And so the vertical shift just means that you start at 2?
I move the whole thing down.
Down.
So watch this. So I'm going to start here,
Yes.
and my first asymptote was where?
I didn't write it down.
Pi over
5 over 4? That was my start, right? Okay, so I have pi over 4, and my second one was where?
5 pi.
5 pi over 4. Yes?
Yeah.
Okay, so now I break up my pieces. So my first part, my first quarter part, right? That was what? Pi over 2, very good. So pi over 2. The next one was what? 3 pi over 4. The next one is? Just pi.
And that's with all the phase shift and everything?
Yes, that's all the phase shift and everything. That's why I did step 6. I did step 6 to get all these things.
Yeah.
So now I have all my pieces. I have, so let's graph step 5. So 5 is the asymptote. So I have here. And I have here.
Apparently not.
Okay. So I have my asymptotes there, right? Okay, so now let's talk about my vertical shift. My vertical shift is what? -2. So I mean the whole graph needs to go down 2. So it's going to be 1, 2. And at my vertical shift, I'm going to draw a dash line going horizontally. Okay, what was my amplitude? -1. So that means it has to go up 1 and down 1. So I need to label these. So it's going to be at -3 and -1, right?
Okay. Oh, so it's just gonna stay down there.
Yes, it's all staying down there.
it start
That makes
like
sense.
the wait.
Okay, Zoe, what was the first dot I always graph?
The starting point fast.
No, the first thing. So when I'm doing tangent, cotangent, do I start by graphing the left and right? No, I always graph the one in the middle. So I graph the one in the middle because the one in the middle is going to end up at my vertical shift. Okay, so I'm going to, that's going to be a red here. So I'm going to right here.
Oh, okay.
Okay?
Because the asymptote is
Isn't it
one.
going down? So yes.
Okay, so now listen. Okay, so we got to go back. This is a cotangent function, right?
Yeah.
Cotangent is supposed to end which way?
Down.
Down. But isn't this a negative cotangent?
So it's gonna go
I have a negative amplitude, don't I?
Yeah.
If there's a negative amplitude, it's going to switch that. Because cotangent is supposed to end down, but a negative means it's going to be the opposite of that. It's the opposite of my cotangent, so instead of ending down, it's going to end up. So that means that my second dot over here is going to be up 1, right? So it's going to be up 1 here. And over here at pi over 2, it's going to be at
-3.
at -3. So I put my dot at -3 there.
Yeah.
Okay? Are we okay here so far? So we're using the shapes of the graph, so I really actually don't even have to plug these in to do the math for these. I just use the shape. Because we know a cotangent is supposed to end down, but a negative cotangent is going to be opposite, so that means it's going to end up. Okay, so now let's go ahead and sketch our graph in here. So if I sketch my graph, it's at the asymptote. And it should look like that.
That was nice.
Good job.
Like I said, I have been practicing this.
Really? Like legit? You've just been like.
Didn't we have this conversation yesterday?
Yes.
Yes.
We did.
Yes, we did. Okay.
Sorry.
All right. Now, questions over this. If you follow the steps,
It's easy.
step by step, yes, it is a lot of work, but it's a lot easier if you have steps and know what to do logically, one after another. No matter what the problem is, do the step. Do the step, and it's going to make all the problems become a whole lot easier.
I didn't write the homework down.
Okay.
Today.
Now, does that make sense?
Yeah.
All right. Questions? Because I'm about ready to finish.
There's no homework.
All right.
There's no homework?
Okay, Emmanuel, you ready to close it out?
No.
All right. So don't forget, like, subscribe. Yay.